welcome everyone. I'm Ádám Sándor. I work as a cloud native architect at Container Solutions. My favorite thing in cloud native is CI/CD and like application delivery. I'm really interested in GitOps and all the latest good things that are coming out in this space. I have worked on different projects with smaller and up to enterprise scale clients of ours to implement good delivery processes and like improve the whole software delivery flow, which I think is really important in cloud native, because you can have Kubernetes, but if you can't deploy in a stable low risk way every day, all the time, then what's the point of having fancy cloud native infrastructure? And particularly GitOps helps achieve this even in an enterprise regulated environment, which actually is like is more frequent than many people think, because already if you're dealing with customer data and whatever, like some sensitive data, you might not want every developer in the company to be able to just do whatever they want to production. And then how to guard that production starts really complicating the CI/CD process. So I will start. I'll share my screen and draw things, because that worked out really well last time. People were quite happy with it instead of showing some slides, which I also have. Yeah, I'll share desktop. All right, so CI/CD. What is this about? Let's just get started with the basics to lay down some really basic stuff. The whole point of CI/CD, we can draw it in the really simplest way, is we have source code and we want to deploy it. And let's even go one step further. We have users, right? So this is, whoops, this keeps happening with Draw.io. Yes, there we have users, and we want to get whatever program we have written in front of our users. And that requires a few fundamental steps that are always there. First of all, we need a production environment that is going to be some kind of infrastructure where our program will run. And we will call this the app. And we want to place this app into production so our users can use it. Now, this requires us to build some kind of artifact from the source code that will be deployed to production. So build artifact. And I'm going to disregard now things like languages where like PHP, where you would maybe without an artifact just check out the Git repo straight into production. We don't, in any kind of more serious operation, you don't really want to do that, even if your chosen language is like JavaScript or PHP. So we want to build an artifact, and to do that, we want to also shift testing as close to the source as possible. So before building the artifact, we want to run as many tests on the source code as possible before, and we call that unit testing. We build this artifact, we want it to be tested already. However, we can't test everything with unit tests. We actually, before we would deploy to the production environment, we want to test the artifact, whether it works together with possibly other services on a test environment. And we might have more environments to where we deploy, and I will move this a bit down here. And this one down here. So we will deploy to a number of environments. Usually I recommend to keep the number of these environments as few as possible. So we build artifact and then we deploy to test, and at some point we deploy to production. And going through this process, we will have different actors in this process. We will have the developers writing the source code. We will have quality assurance doing the testing, and this doesn't have to be necessarily different people, but at least there are different roles. Q&A. And in a regulated environment, there might also be some kind of release management to make sure that, or either operations or release management to approve changes, to production environments. So the flow of work goes like this for a single service. And then of course there are many services and everything gets more complicated in real life. And what happens, so, and to talk about CI/CD, which is a quite interesting term because it's a kind of an amalgamation of, like it's this whole process, but actually two parts of it are quite different. So there is the CI part, which is here on the left side, and CI we can think of, continuous integration, as the process all the way until we get something, until we build our artifact. And after the artifact is built, and actually continuous integration means that we integrate our code very often to run unit tests on it. So originally, people, when continuous integration was invented, were not really thinking about the deployment to production was a whole separate concern, and nobody cared about that, at least not in development circles. And continuous delivery, the CD part has been quote unquote invented later to deal with the problem of whatever we build in continuous integration. If we do a lot of manual work afterwards, we can integrate our code as often as we want if at the end this artifact that we build here is going to be deployed to production every 6 months. Then the whole continuous integration thing will not matter a bit. So the whole CI/CD process, it's very important to realize, is we have to look into bottlenecks in this process, and basically we have to unplug this process and have to make this flow as smooth as possible to production, even in the case of a regulated environment where maybe operations and release managers are involved in this. And there is QA and maybe there is manual QA, which is a completely reasonable thing. I have never seen a company where they would have achieved the complete automation of QA. So these two roles, sometimes people idealistically refer to these, that you just have to automate away these roles. I have not seen that really happen. If you have, then please tell me that somewhere happens, and that would give me hope. So with this, we have defined what we mean by CI/CD. Does anybody have questions or maybe remarks on, like, no, this is not what I understand under CI/CD? No? Okay, then I assume everybody agrees. So let's move on to cloud native CI/CD. How does cloud native CI/CD differ from normal CI/CD? Cloud native CI/CD, let's make it simple and just say it's Docker, it's CI/CD that uses Docker and deploys to Kubernetes. So this test environment is, let's say, a Kubernetes namespace. And this production environment also equals a Kubernetes namespace. It's getting ugly here a bit, but yeah, it's okay. And this app is actually a Docker container, right? That's yeah, this became really ugly for some reason. Spacing, no. Yes, there. Okay, so this app is a Docker container. So Docker standardizes the deliverable that we deliver out of this process, and Kubernetes, building on that standardization, can deploy it and run it. So these are the very important steps, because before Docker, out of this process could come a lot of different types of artifacts depending on the technology stack. Java would produce a var file or a jar file. Node.js would produce a bunch of just a zip file. I don't know what Python does. Go would produce an executable file. And then it's very hard to build a consistent deployment process, because all depends on the technology that you happen to be using in this process. So in a larger environment where there are many different applications built with different technologies, this all becomes very, very complicated with all kinds of different deployment scripting. Now with Kubernetes and Docker, this all becomes very standard. So Docker container, whatever language the source code is written in, will look always the same from the point of view of Kubernetes, and Kubernetes will be able to run it. Now let's take a look at what does that Kubernetes runs it really mean. So here we have our production environment, and this is a Kubernetes namespace. It might be that on the same cluster we have multiple production environments for different applications. For example, we might even be having non-prod and prod environments on the same cluster. It doesn't really matter. We will now, 1 hour is too short time to like really go into more complicated things. So let's just focus on deploying our app on Kubernetes. The deployment on Kubernetes means that Kubernetes has an API server, and into the API server we will put some objects. So this is the Kubernetes API, and into this, and I'll zoom in a bit so everybody can see it. By the way, if something is not clear, please interrupt me at any moment, or if you don't see something or whatever, if the font is too small or anything else that is not clear, just shout. Yeah, so Kubernetes API, let's make this, move this to the top, and let's put some more text here. So when I'm deploying something to Kubernetes, what I'm actually doing is creating a deployment object in the Kubernetes API. It will have a name, will be my app, and it will be image, and the image will be my app, or just we called it app before, so let's just keep calling it app v1. This is basically a YAML file that I send to the Kubernetes API server, and it gets stored in etcd in the background. So my deployment is basically send application definition to Kubernetes. How can I zoom? Ah, yeah, there. Whoops. And once I insert this into the Kubernetes API, Kubernetes will actually create an application container, download the image from the image registry where I uploaded it at the end of the CI process, and will run my application probably together with all kinds of other applications in the same environment. This is app2, app3, that are also, of course, defined in the Kubernetes API server. And now comes the interesting part about GitOps. So the problem with this, if I'm implementing these processes here, there is a CI process from source to building an image. There is a test deployment process and the production deployment process. We now will assume that production and test deployment is very, very similar. So I will only be talking about the production because that has kind of the more heavy requirements. And let's say that my company is regulated, or for many other reasons, I'm just not trusting developers to be making easily making changes to production environments without review. I want to have a review, and I want to have an audit log, and I want to have a nice way to roll back if something happens. So what I can do, when this send application definition here, this is YAML files, basically, actually running kubectl apply, for those who are familiar with Kubernetes. And what I can do is, I need to draw here all the applications that are running in this to make things clear. So name is other app, image is, yeah, so this would be, okay, let's just stick to what I already used. App2 version 44, and another deployment. Of course, there are all kinds of other objects in Kubernetes also at this point, but I'm just focusing on these. F3 v23. So what I can do to have an audited record of intended changes to this environment, I can create a Git repo, and I can use Git to fully version all my environment changes and basically manage every change to the environment through Git. And this is what we call GitOps. Basically, I just put all my YAML files. It always uses the latest font that I used. Anyways, that's okay. And in this Git repo, I will have all the YAML files as soon as I figure out the text indenting. Yes. So I will have app1 deploy.yaml here, app2 deploy.yaml here, and app3 deploy.yaml here. And it's very simple. Inside this YAML file, of course, is the deployment, and also it contains the image is app v1. So whenever I update this Git repo, the send application definition step kicks in, which this step can run in some CI tool. Let's say, yeah, it's good to show where I would be running all these things. So this is a, whoops. Okay. So this in the top is a logical view of the whole process. This is the deployment, the GitOps view. And another view would be that I would have Jenkins or GitLab CI or any kind of tool like this. Basically, these are all CI tools, which are just generic like pipeline execution tools. So GitLab, Jenkins, Circle CI, whatever else you like to use. And inside this, I will have a few pipelines. I will have a CI pipeline, of course, many CI pipelines, because for all my applications, I will have a deploy to test pipeline. And in case of many test environments, I'll have multiple of those too, and a deploy to prod pipeline. And this step here, we will call the sync to prod pipeline. And I will explain why that's not the deploy to prod pipeline. So what we do here, instead of we calling this send application definition, we'll call this sync, the sync step, sync to prod step. And this could be put same into the CI, into the tool where you're running your CI and deployment pipelines and everything. So we start managing our environment completely through Git. This means we can have developers initiate intended changes to the environment. So I can draw an arrow from this guy's leg to there and say, I want to update version of app 1. And this will look a bit ugly here, but yeah, it's visible. And then the operations person can say, I will merge your pull request. Thank you. I accept your change by merging your PR. Right? So with a normal Git workflow, we can have a pretty sophisticated release management workflow. Developers create pull requests and operations accept it. This way, developers can also make comments on what are they changing and why, and operations can read that. And at the moment operations merges that pull request, this sync process kicks in and it deploys the YAML files. It goes over all the YAML files and deploys them to Kubernetes. And this is the basic idea of GitOps. Basically, managing your environment completely through Git. And then a small addition to this is that you could do this instead of writing a little pipeline yourself. You can use Flux, Argo CD, or Jenkins X to do this synchronization. And these tools are specially made to, especially Flux and Argo CD, they are designed to execute this synchronization step. Jenkins X actually does the CI and also implements a whole GitOps workflow. We have a demo actually using Jenkins X of GitOps prepared. My colleague Rafal is ready to jump in any moment, but I would like to stop now and ask for questions. And also I have a few more smaller things to explain, but I need to take a sip of my coffee and would like to hear what do you guys think so far. Any thoughts or questions, or is everybody still here?
I'm here.
Yeah.
I really appreciated how you build it from scratch. I think it was a very, very clear and how to say, useful way to see it building step by step. So even
Thank you.
I'm not, you know, I'm not a developer, but this helps a lot with the grasping the concept. So I hope it was useful for the others as well.
So I got a question. So Adam, in your experience, what is still the biggest challenge to actually go from a non-GitOps way, a more traditional way, to a GitOps workflow like the one you described? What would be the top challenge or top 3 challenges that you saw in the past being really difficult to overcome to reach that stage?
Yeah, I think so. Implementing GitOps is not very difficult. There is one awkward part about GitOps actually, and that's the fact that updating this repo here, depending on the frequency of your deployments, this might not be convenient to do manually. So going after you have built your artifact, and now you want to deploy to test, or you want to deploy to production, and let's say you have 2 of these repos, one corresponding to production and one to test, going every time to this repo to edit the version number here is like pretty inconvenient. So you want your CI process maybe to end with a pull request creation on the test environment repo. And the problem with that is that simply Git is not exactly a tool that is perfect for like programmatic manipulation, right? So it's not a database that is designed for that. So it's more designed for people to be cloning a repo, editing some text files, and then committing and pushing. So that part is a bit awkward when you want to automate the writing into the Git repo, and you do want to automate it when you're deploying applications, because it will happen often. And so that's completely doable. It's not like very hard, but actually there are not really tools, except Jenkins X does this part also. That's why this deploy to test and deploy to prod, these pipelines actually in a GitOps workflow, they don't actually execute the deployment to Kubernetes, they write into the GitOps repo. Yeah. And this is a bit of a, yeah, this is something you need to implement. The syncing, there are tools, and you can also roll your own. So that's not such a huge problem. I think more
Yeah, for that part, before Flux and Argo and Jenkins were in the landscape, I've seen sometimes people were writing Lambda functions or any basically event-based functionality that actually would do this synchronization. It would get messy or not very clean, but it did.
Yeah.
It did the synchronization. But yeah.
Yeah, it's the real question, I think, is when is GitOps the right thing to use, right? Because if you don't need this audit trail, if you don't need developers to be segregated from the production environment, then you don't. Then I'm not sure. Like, I know that the guys at WeWork who made Flux, they also invented the term GitOps, and I know they would recommend GitOps for any workflow. Their Weave Cloud just does GitOps all the time. That's the interface that you do. And it's fine, but it does complicate things. So also what Flux does is it monitors this environment here and monitors for any kind of change that happens on the environment, but not from Git, because of course, this cluster is not sealed.
Yeah.
An operator can go here and launch app4, which is not represented in Git, and Flux would nicely detect that and alert you. But then again, it's adding complexity. So GitOps is not a silver bullet. And then when you scale really big, then suddenly you end up managing tons of these Git repos that are holding your environment state. So at that time, GitOps becomes a bit of a like poor man's release management tool. But because we don't have very good release management tools anyway, unless companies have built something for their own like internal stuff that actually works well, GitOps is still is pretty good. But that you're stretching it as everything when you're like scaling it to like hundreds of teams, let's say.
Yeah, makes sense.
However, what I really love about GitOps is that whenever companies do build their own release management tools, they're usually much more complicated than this simple process here. Because of course, in continuous delivery, you want to go fast from source to production. But the fact that this step, this compliance step needs to be here, that makes companies start thinking about production deployments as something very special and very different from everything else. And then they forget about the automation also. So like they start thinking about, yeah, okay, so we deliver to test, and after that something happens. Anyway, there needs to be an approval, so who cares? We can like ship that Docker container on a floppy disk to production. It doesn't matter anymore. While it actually does. And this type of process where developers already programmatically like initiate this change, there is a diffing, there is a very clear technical thing happening here, not a million fields to be filled in some change management tool, but just a very clear diff. And at the moment this guy pushes the button to merge the pull request, the sync process kicks in and it's there. That is also a very crucial point about GitOps, that once you change the Git repo, you immediately sync to the cluster. There is no more process in between here, no more approval steps, but you sync to the cluster. The only exception to that is if you do things like canary releases, because then something more complex needs to happen after the Git merge, then this is your intended state. And you might get there through a whole process of increasing traffic to the canary release and all these things. Which actually, by the way, happens on Kubernetes automatically, because anytime you change things in the API server, actually there will be a rolling upgrade. So that also doesn't just magically replace the version of the app, it will actually run a rolling upgrade process. So there will be a process that is not actually captured in Git. And you have to watch out for it to see whether it actually finishes and you do get the state that you want it to have.
Yeah, and you have tools like service mesh that usually also accommodate canaries and canary deployments and different strategies, right? So you just don't have to have only a pure Kubernetes namespace. But yeah, makes sense.
Yeah, so for canaries, actually in the afternoon session, we did the canary thing, and it's like you need basically 3 components there. You need Istio, because you need to somehow be able to direct the traffic to the canary version of the application. And I'm trying to like style this somehow that, okay, this will be different color. You need Prometheus to track some metrics about whether the canary is working and is not producing errors compared to the original version of the application. And then you need a control plane for this, and that's Flagger, that takes the data from Prometheus and changes the ratio of the traffic through Istio. And then yeah, Istio manages things inside Kubernetes, which this is what this looks like right now, but yeah. So this would be the canary deployment flow that completely goes outside of GitOps. However, it's also possible to do it through GitOps if you don't want to make it so super dynamic, but you can just like change from 20% to 60%. You can manage all this in Git also. Depends on, until things are not too dynamic, things can be managed also with Git. But when things become like, okay, I'm increasing the percentage automatically based on metrics, I'm watching my application, then that's not something you want to do through Git, because every change is a commit to Git, and that's crazy. Any questions, or shall we jump to the demo?
So in what you just explained with the canaries there, does Istio act as an ingress controller into the cluster?
Yes. Yes.
Okay, and it's got presumably got some logic built into it to decide how the traffic's routed.
Yes. So in Istio, you have to exactly tell it how to route the traffic, and it can do things like 10% of the traffic to this one and 10% to this one. It acts kind of like a Kubernetes service, but with the extra parameters to be able to control how the traffic flows. Okay. But that means that in itself, Istio is not enough to execute a canary deployment, because you will need some kind of control plane, and you will need some kind of like some metrics to decide based on.
Okay.
And it is, I think, this picture like this really shows like the whole and the cloud native continuous delivery workflow. Because also why this is why GitOps can't be done just in any environment is because to be able to do this sync process, you need declarative configuration. So you can't have scripts in Git that would like execute, because what happens whenever Git changes, you can't figure out what has changed. The nice thing about having this declarative configuration is you can always just iterate through all the files and apply them to Kubernetes, because it's declarative. So if you reapply a file where nothing has changed, nothing will happen in Kubernetes. And Kubernetes takes care of the actual comparison which needs to happen when something changes here, and then it compares what's really running on the cluster and then makes the changes happen actually on the cluster. So all the heavy lifting is done by Kubernetes. Without this declarative configuration, GitOps is not feasible or useful at all. Cool. Any more questions? Okay, then I will have one last thing I want to mention, and then we jump into the demo, Rafał. Organizationally, we already showed here that developers and operations can nicely work together on this repo. And both security-wise and like workflow-wise, this repo actually does a very good job of separating concerns. Basically, this becomes a demarcation line between operations and development. Right? So developers don't have access to the cluster, or maybe they have read-only access to the cluster. It's not about like really completely kicking them out. They should have access to log aggregation. They should have access to Prometheus and whatever. We want to give them maximum access, and we want them to be able to be responsible for their applications. So this is not about breaking DevOps. This is just like kind of accepting the realities of regulated environments and getting as close to ideal DevOps as possible. And this repo here basically can become that line where developers can like request changes and then operations can merge them. And the same process can work for any other environment which is not security critical, like the test environment. Just in that case, we remove operations from the picture and developers can just make changes to this repo. So basically the heavy production deployment process and the lightweight test environment deployment process will look exactly the same, except a few checkboxes on the Git repo will look different. This is, I think, a very, very nice property for GitOps. It also means that in companies where, let's say, QA is guarding the test environment even, you can just go very easily from that old school process to a newer one by just changing the configuration of how you manage the Git repo. Okay, and now I'm ready to shut up and hand over to Rafał. You ready, Rafał?
Yes, I am. So thank you,
Awesome.
Adam.
Please before you jump in, just explain a few words about Jenkins X. So nobody thinks it's Jenkins.
Yes, true. Let me share my screen. Hope you can see it.
yeah, we can see it.
Cool. Yeah. So Jenkins X is it's kind of a new version of Jenkins itself, but actually it doesn't look like Jenkins at all. I would say the classic Jenkins that we all know. So I think it's a new, like it's a very ambitious project trying to implement a GitOps workflow, but it also covers the CI part, which usually it used to be like the core of the old Jenkins. So based on what Adam just presented, I think I would like to show how to apply GitOps like deployments based on the concepts of having like a change being applied to a Git repo and then having like your GitOps engine, let's say in this case Jenkins X, applying that change to the cluster. So in my default installation here, so Jenkins creates for me like 3 repositories. So those 3 here in the top listed here. So the first one is the dev environment, which is the environment where Jenkins keeps its own configurations, right? So, and there are other 2 environments, the production and staging here. So each one of those 3, they are mapping a real repository. So for example, I can show you here. Yeah, so there is this repository kind of mapping the staging environment, and there is another one here mapping the production environment, right? So when I was installing Jenkins X, it requested me some permissions, some API tokens, and it creates those repositories for me. So, and the idea, yes, go ahead.
The one remark, Jenkins X is basically the only tool currently that like does this full GitOps, everything I drew up on that board before, including the Flagger and Canary release part. Jenkins X sets up and manages all of that with its own tooling. So all the parts, the CI process, and it implements the CI and deployment processes using Tecton under the hood. So originally it was using actually Jenkins under the hood. Now it's using Tecton under the hood to execute processes, but actually puts an abstraction layer over all of this and basically lets you manage everything through Git repos. So it's a very big project, and it's very hard to actually fit into an like existing environment if you're not starting from scratch, because of the fact that it like does everything. However, it's very, very good for demo purposes because it really does the right thing. So it's very good as a reference implementation of a full cloud native CI/CD process. And also if you are starting from scratch, then this is a great tool that like does it all basically. Yeah, continue, Rafael.
Cool. So here mapping the environment, staging and production. So there's another tab just to show the state and the list of applications running on those environments. So you can see like this application here, JX Quick Start Go app. So it is running production on version 003. And the version in staging is 005, right? So in order to upgrade this version in production, so as it was like explained by Adam, so I'd like to send a pull request to this production Git repo, and then Jenkins X would be able to apply that change. So yeah, before the call here, so I just like created a pull request here. So I have that already like ready here. So in a real scenario, so let's say I am a developer and I don't have access to this repository, right? Or maybe I don't have write access, but I could just create pull request. And let's say, since it's already prepared here, so Adam is already was already asked to review this change. And not sure if you want to try right now, Adam, but if you just comment.
Oh yeah, here. Yeah. Let's do it. Let me. I'm gonna be operations, and I'm going to review the change. Just need to shut down Slack. Just a moment. Where you sent me the link for the repo.
Yeah, I can copy and paste here in the chat so other people can also follow.
Oh yeah, okay. That's also fine. In the meanwhile, I'm.
Well, I think I cannot see the chat. Oh, here it is. More chat.
Yep, I'm opening the repo right now.
Hope you can see that.
Okay, I'm going to be happy with your looks good to me.
Yeah, just explaining. So that's a nice feature. So yeah, I can see you comment here. And the bot is already like picking up what it did. So it already, based on your command here, so it already tagged this PR as looks good to me, which means someone has already like looked into that change and both approved and sent a tag, looks good to me. So some rules can be applied based on those tags, which is pretty cool. And based on that tag, so this job will run. This is kind of a periodic job. So tide, it references like the tide of the ocean goes up and down, which means runs every, like, I don't know what is the period that it runs. So previously it was requesting the approved label, but after the comment from Adam, it has been approved and it has the label ready. So once this job runs again, it will just like merge automatically the PR for me. Let me refresh the page. Oh yeah, it was already merged. So this is a very nice feature from Jenkins X. It already configures this like on the default installation for you. So I didn't have to change anything specifically to that. So that's pretty cool. So on top of the GitOps workflow, so Jenkins X does it based on let's say GitHub workflow with pull requests, right? So here I'm mostly using like GitHub like functionality, sending a pull request to a regular repo, and there are a few hooks and a few actions happening behind, like it runs a few tests. If this is a project that has tests, and this bot like is watching and getting the notifications when someone comments out here, and especially when someone comments an action, which is like it's and action, they look like a slash action name. So it looks good to me. It's an action that someone has reviewed and approved this PR. And if this person is from the list of people that can approve, so the bot will like recognize that and just approve the PR and automatically merged to master. So we can go back here to the environment. So let me see if something will happen here. So yeah, I can see on the builds here that something is running. So the promotion pipeline is running. So based on this pull request here. So it may take like 1 or 2 minutes. So the build is there. Okay, that's great. So I can come back to the environment. So the pod is probably restarting inside the cluster. And at the end, so I would like to see a state like ready and this version here updated. So, and again, the interesting part that so we can like just send another pull request to see how that was initiated, but there is no like push button explicitly. So everything was initiated by pull request. So while we are waiting here, so let me try to create yet another pull request. So this pull request was to try to upgrade this version from 3 to 4, right? So let's create a new one to upgrade to version 5, which is already there in staging. So
can you use JX promote for that? Is that what you're gonna do?
So I would just like create a pull request like from the code. Is it helpful or not really? Just to see like that I initiated that flow from my like development workflow. I didn't have to push any button,
okay,
just to create another pull request. Or yeah, I think Adam is asking that because I could do this based on a command line, and I have the command here. So that's the repo from the application. I just pasted here as a reference. So Jenkins X has a very nice command line tool called JX, right? There are lots of options here. So actually maybe too many of them. So I could actually promote an application. Oh, sorry. Already triggered. So I could promote that application with this command line. So, and the parameters here, let me clean this. So I would specify the app name and version right? And which environment that I want to target this promotion. So that's helpful at the beginning to figure out what should be changed. So yeah, so I could see what application version is running to from here. So that's something that I already can see from the UI, but I can see here this application. This is the version running stage. I have one pod. That's the URL if I want to go and check the actual application running. So here it is, it's just a hello. And here another column in production. It has, oh, I can see it already got upgraded to version 4. And then again, the URL. So yeah, so that's pretty interesting. Let's say if I would like to upgrade to version 5, which means like promotes the version that's already in staging to production. So I could run this command here if my JX have the proper access to the cluster. If my kube config
to Git,
access.
right? It has access to Git basically, because what a promotion in Jenkins X means is actually creating a pull request on that production repo.
Yes, that's true. Yeah. So this one, actually, I need to talk to the cluster because yeah, the cluster from inside the cluster, Jenkins X will create a pull request to the right repo. So
yep, yeah. So you need both. Okay. So it's not the JX command line tool that actually accesses the Git repo, but it's Jenkins X running on the cluster.
True. Yeah. JX. Yeah. Also always talks to the server side. Let's say running the cluster, and from there, like things happen. So yeah.
Right.
So here I have cloned those repos, right? So those three repos and my application here. So I'm gonna go to the environment production repo. And so I'm gonna go back to master. If that change was already merged, so I should see something here that was changed. So git show, that's a merge commit, so it doesn't have anything. So, okay, so what I want to do is I want to go to this file here and just change the version of the application. So again, so this is the repository that maps the production environment. So as Adam just said, so instead of that just pushing a button somewhere or open a Jira ticket or calling ops, so I would actually go to this repo. Supposedly, let's say I only have like read access, but I could create pull requests, right? So I would change the versions of things that I want to change in the production environment, and I would commit that. So yeah, let's create a branch, check out with a branch name, promote version. So promote another version to prod, and then I can push RNG and promote version that was the one I just created. So there is nothing new here. So it's just like my regular Git workflow with, in this case, GitHub. So I got a message from GitHub, so saying that I could use this link to create a pull request. So I'm gonna go there. So again, this is the repo mapping the production environment, right? So let's say, you just say that I push like promote version branch, and I would like to create a pull request to master. Please apply this change to production. I could explain what I'm doing here, and I would just create a pull request. So yeah. So you can see Adam was already assigned as a reviewer here. So the bot's already like posting a comment here explaining what should happen. List of comments can be found here. I could assign this PR to another person, right? Assign and at mark the name of the Git user. So the owners is just like a regular file inside the project saying who are the owners of this project, and they are the ones allowed to to approve. So, and that's pretty much the same state that we were before. So again, so I would supposedly, like Adam would get an email saying that he was assigned to this pull request, or I would go to his desk and ask him to review this PR for me. And if he's fine, he would again just comment here, looks good to me, or approve, and the bot would consider that and just merge the request. So that's pretty much the full workflow for deployment, right? So I just go to the repository, the Git repository, mapping that environment that I want to deploy to. So I make a change on the repository, and Jenkins X behind the hoods applies things to me and helps me with this interaction here, which is pretty cool. Yeah.
Cool. Thank you very much, Rafael. I'll take it back now to wrap things up as we are running out of time. Before I think we can run a little bit over time. I let you guys ask some more questions, but before that, let me just quickly recap this thing that Rafa showed. But on that drawing I did, so you understand better what's happened there. So what Jenkins X did, we didn't show this part, but it does this part with the with building a Docker image actually from source. So it will create a Tecton pipeline that does this. Then the deploy to test step, that's it actually at the end of the CI pipeline, it will create a pull request against the Git repository for the test environment. Then when Rafa called JX promote, then we went from deploy to test to deploy to prod by creating another pull request. And Jenkins X, whenever this repo changes, there is going to be a Tecton pipeline that Jenkins X has created that will do this synchronization step here to the Kubernetes API. And as you saw on the Jenkins X UI, it will even watch whether the pod that will start up properly. And something I've never tested before, but actually this part with Flagger and Prometheus and Istio, it also implements this one for this is their newest feature. And I've seen some people from CloudBees actually demoing this, the Canary release functionality in Jenkins X. So yeah, so Jenkins X is not the only way to do GitOps, but it's the only tool actually currently that like does this whole shebang in one tool by basically orchestrating many other tools. So it doesn't like it uses Tecton, it uses Istio, Flagger, Prometheus, uses Vault for secret management, and Git basically for all the Git stuff. Yeah, that's it. So, are there any questions or remarks before we wrap up?
Just a quick question on Jenkins X. Does it support some kind of feedback mechanism for when deployments fail to roll out? Say your deployment's failed and there's a 10-minute time window's passed. Will it send you a notification?
Yeah, it has integration with Slack, for example. I'm not sure about the full capabilities of this, but at the very least, it has some ChatOps functionality built in, and it can notify on Slack.
But I would expect like you to see like a build failing, right? So when you change a repository, so from your application or a repository that maps an environment, so that change triggers a pipeline, right? And that pipeline would possibly fail if something is wrong there. Right, or in another step, so if changes are applied correctly, but the application does not start, so that would be like another step that should be covered somehow. Maybe your application is not like sending the correct metrics, and you should capture that to realize, oh, the deployment didn't succeed, so I need to revert or reapply a previous version. Yeah.
Okay, thank you.
Cool. Any more questions? if not, then well, thank you very much for joining us. Just a small reminder that we are actually a professional services company. So if anytime you would need some experts to help your company implement this kind of CI/CD process or other help with cloud native infrastructure, that we're here to help. And yeah, we will have more sessions like this, what you can join. So yeah, stay tuned.
Yeah, any feedback is very much appreciated, even on sessions that you would like to see in the future that we haven't covered yet, or if you remember a question that you didn't ask online. So you can reach out to us whenever you feel like. But thank you so much, Adrian, Adam, and Rafael for this great session.
Yeah, thanks Carla for organizing it, and thank you guys for joining.